Again, we're on page 38. We'll start with our quick look at the calendar. We just took our first quest. I'll give it back at the end of class today. We start a new topic, additional properties of lines is today. Next week we have 3 days of class, Monday, Wednesday, Friday as usual, but I'll point out that Friday, 1 week from today, I don't have any agenda. I just want to make sure that people have a chance to catch up if they're falling behind in anything. So that will just be our catch-up day. Friday, 1 week from today. So Monday and Wednesday, new material, as you can see. And then Friday is our catch-up day. And then Monday, no rest for the weary, is our very next quest. So not this coming Monday, but a week from this coming Monday is our next quest. Mary? I'll take any old homework between now and Quest 2. I will take it up until that date of Quest 2. But as of this moment, I don't take any homework that was from before Quest 1. Okay? All right, so that's what's coming. And let's start at the top of page 38 with the daily summary. Yes? So it's not, so don't think of Friday as a makeup day. Maybe I should rephrase the way that it's listed here on the calendar. We have a quest coming up the Monday. Think of Friday as the review day. That's an opportunity for you to come in, maybe do the practice quest problems that are in the packet that nobody's done yet because you didn't know that they were there, and get your questions answered. You can skip Friday's class just like you could skip any other class, but I would encourage you not to think of it as a I'm only coming in to turn in old homework. Okay, good question. All right, can we go to Lydia for the daily summary, page 38? Okay, thank you. So let's start with the demo number 1 here. We've got 3 points, 7, 2, -4, 2, and 0, 2. Take 10 seconds to plot those 3 points. Plot all 3 points on your grid. And then we move on to part B. It says, what word describes the line connecting these points? So when we draw that line, the word starts with H, horizontal. And horizontal lines are one of the special kinds of lines that we're talking about today. Horizontal, vertical, parallel, and perpendicular. Now let's write the equation for the line that passes through those points. All right, so far, most of our equations of lines have looked like y equals mx plus b. I'm going to put a line through that and just say that when you have a special line, like a vertical or a horizontal line, potentially y equals mx plus b isn't going to get it done. And so I would rather us think about this intuitively. What is consistently the same for all 3 of these points, like just looking at those numbers? The 2. And which one is the 2? Is the y value, right? So y is equal to 2 at all 3 of those points, and in fact, that's the equation of that line. So it's very intuitive. You just say, what's consistent? Oh, I see a bunch of 2's that are all the same, and where is that 2 located? It's in the y coordinate. So y equals 2 is the equation of that line. If we wanted to, we could calculate the slope of that line. Let's go ahead and do it real quick. I'm going to use these 2 coordinates to find the slope. Which one goes on top when we do our slope calculation? Change in x or change in y? Change in y. So we're going to subtract the y's, 2 minus 2 over, subtract the x's, maybe 7 minus -4. It's okay if you have that in the opposite order. Change in y over change in x. Upstairs we get 0. Downstairs it hardly matters, but in this case 11. And how much is 0 over 11? It is 0. So what is the slope of that line? It is 0. And in fact, it's true for any horizontal line. The slope is 0 because you don't rise at all, right? You do a lot of running on this line, but no rising. So it's always going to be a 0 on top. Okay, same idea for number 2. Here I'm giving you 3 new points and a brand new grid. 4 comma 2, 4 comma 5, 4 comma negative 3. Take 10 seconds to plot those 3 points. And then go ahead and draw the line that connects all 3 of those points. What word describes that special line? Vertical. And again, if we want to get an equation of the line, I'd encourage you to forget mx plus b, but rather just think intuitively. Looking at the coordinates of these 3 points, what's the same every time? Is the 4, and where is that located in each point? It's the x, so the equation of this line is x equals 4. That is the common thread for those 3 points. The x coordinate is always 4. All right, let's go ahead and calculate the slope here. Again, I'll use the first 2 points. We know slope is change in y over change in x. So upstairs, we're going to put either 5 minus 2 or 2 minus 5. Downstairs, 4 minus 4. So on top, we get 3. On the bottom, we get 0. What can you say about a fraction 3 over 0? It's undefined. It isn't 0. 3 divided by 0 is undefined. So that means that the slope of this vertical line is undefined. And the slope of every vertical line is undefined. Because when you're doing rise over run on a vertical line, you got lots of rising happening, but no running at all, which means the bottom is always going to be 0 for this slope calculation. Some students like to say that this has no slope. And I can appreciate that from like an English language perspective. Like, it just doesn't exist. You can say, there are no elephants that are purple, right? Like you're saying that they're, all right, maybe. Apparently that's controversial for Nate. But I don't want you to say that there's no slope, because the word no in English might also mean 0. For example, I have no oranges. And so undefined and 0 are 2 completely different answers here. So I'm not looking for you to say no slope. I'm looking for you to use that word, undefined, okay? All right, so our conclusions. Let's go to Kira for, 1 second. Cody. The x equals 4. So it was very intuitive. We looked at the coordinates of these 3 points, and we asked ourselves what was the same. We recognized that there was a 4 sitting in the x coordinate. So for every one of those points, x was equal to 4. And in fact, that's true for any point on this line. Every one of these guys satisfies the condition that x equals 4, and that's the equation of the line. Okay, Kira, can you read number 3? Okay, let's fill in the blank. The choices are y equals a number and x equals a number. Horizontal line. Which one is it? Y equals some number. Go ahead, Kira. The choices are 0 and undefined. 0. That's what we saw up above in example 1. Keep going. Okay, every vertical line looks like x equals a number. Undefined. Okay, so like half of what I want you to take away from today's class is in those 4 sentences right there. I don't think it's something to memorize because the two lines are quite similar to each other, and if you're not quite sure which one is the right answer, then half the time you're probably going to get it wrong, and those aren't great odds when you're taking a test. So I'd much prefer that you think about things intuitively like we did there, as opposed to trying to memorize these 4 facts up here. Okay, let's go to Dan for number 4. Go ahead. Okay, you don't need to draw a picture. You just need to write the equation of the line. Don't think mx plus b. That's not what we're doing with vertical and horizontal lines. If I say undefined slope, which case are we in? We're in this bottom row, right? Undefined slope. And the equation of any line in that second row is x equals a number. So that's half the battle. X equals. It's a little detective game you got to play. All right, the only other info we have is the 0.5, -7. You just have to decide what x is equal to at that point. Which number? It's 5. You just read it off from the point. And that's the answer to this problem. Fiona for B. Again, you don't need to draw a picture. You just need to grab onto the first piece of info, m equals 0. Are we in the first row or second row of our conclusions? First row. And any line in that first row looks like y equals some number. So y equals, that's half the battle. And then read off the y from that point, it's 2. Okay, that is all we're going to say about horizontal and vertical lines. Move on to the next page, where we begin talking about parallel and perpendicular lines. Number 5, Virginia. Okay, so those 3 lines are said to be parallel. Which means they'd go on forever and never touch each other, right? And now I want you to focus on the 3 equations that are given on that graph and identify what they have in common. What's the same in all 3 equations? Is the 2, right? Yeah, that 2x is exactly the same in all 3 equations. And what is that 2 called for these lines? It's the slope. We know that if the lines look like y equals mx plus b, then the m is the slope. And so the slope is 2 for all of these guys. So what do the equations have in common? They all have the same slope. I'll put in parentheses here that the slope is 2, but that's not really important. It's just that it's all the same. And so here is our next important fact for today's class. 2 lines are parallel if their slopes are equal. And then there's some symbols, m1 equals m2, trying to identify the slopes of the 2 lines, but more important is the English version than the notation version. 2 lines are parallel if their slopes are equal. And then moving on to number 7, I have 2 perpendicular lines graphed here. And then there are a few points that I've identified on L1 and another 2 points on L2. So what we're going to do is find the slope of line 1 and find the slope of line 2. Just divvy up the work at your table. So half of you find one and half of you find the other, and then let's come back together in a minute. Let's leave these slopes in fraction form. On the quest, some of you showed me the clear preference that you have for decimals over fractions. I pity you that you hate fractions as much as you do, clearly. But the downside with decimals sometimes is that you don't get to see the actual relationships because you're rounding or you've got a decimal that goes forever. So fractions are not something to be avoided as much as some of us like. All right, so my 2 slopes are -2/3 for L1 and then +3/2 for L2. And there's a real nice relationship between these 2 lines. Forgetting the negative sign, 2/3 and 3/2, what are they called with respect to each other? Reciprocals, right? You guys have seen that word before? So 2 lines, 2 fractions are reciprocals if one of them is just a flipped over version of the other. And then the other relationship here is that one of these numbers is negative and one of these numbers is positive. And it turns out that if you have perpendicular lines, those 2 things will always be the case for the slopes. One will be positive, one will be negative. And the 2 fractions themselves will be reciprocals of each other. So that's here in number 8. Slopes of perpendicular lines. If lines L1 and L2 are perpendicular, non-vertical lines, then the slope of one line is the opposite reciprocal of the slope of the other line. Opposite reciprocal. Opposite meaning the other sign, right? Okay, so big conclusion. We started with horizontal and vertical lines. I need you to know two things about each of those. I need you to know the equation, x equals a number or y equals a number, and I need you to know the slope, 0 or undefined. And then finally, when you have two lines together, I need you to understand that if they're parallel, their slopes are equal, and if they're perpendicular, their slopes are opposite and reciprocal. Okay, the activity is there. I think that you have plenty of time if you're working efficiently to get all the way through this activity and then get a good jump on the homework assignment for the weekend. Get started.